PowerPoint?
Yeah.
Very good. So we talk about we talked a bit about the history. I don't want to repeat it again, but I remember we were here, but I will start here. So as I said, in 19th century, there was a fight, a kind of challenge to decide which type of system is better for the future of power system. There had been two options, DC and AC system. Probably all of you know what are the definition. Can you define what's the difference between AC and DC? One guy answer, please. No one knows? No one?
DC is direct current, and AC is what do you call it? Shifting the sine curve is plus and minus, going up and down.
Okay, yeah, that's right. Probably all of you know it, but probably you feel shy to answer. So let's go. Yes, there was a fight to decide which one is better. Edison is started with the DC system. He invented a power system with 87 consumer in the New York in 1882, and it was a DC. The generator produced DC current, DC voltage, and the value of voltage was 100. So according to electrical power engineering knowledge, it's a low voltage compared to our voltage level we have. It's kilovolt. So it was low voltage. However, we had a problem with the low voltage. According to the power, is very simple expression for power. Power is voltage times current. So if we want to increase the power with the low voltage, we have to increase the current according to this expression. However, if we increase the current, we'll have some disadvantages. For example, the wire will be very expensive. They will be very heavy. It will be difficult to mount it on the transmission tower. On the other hand, according to the circuit theory, the voltage on the terminal of customer will reduce when you increase the current. So you can see it. Consider a diagram, very simple diagram for the power system. You have the source here. It is equivalent, resistor is equivalent for the load, and you have the wire. According to this principle, if you increase the current, you decrease the voltage and across the terminal of the consumer. So it's not good. As you know, we have many equipment that they need a specific voltage. So we cannot reduce the voltage on the terminal of consumer. So increasing the current is not a good option. So maybe one can say we can decrease the resistance of wire. So if we increase and decrease, they can make it constant here. However, what happens if we decrease the resistance of wire? So it's the expression for the resistance of wire. So it's the length of wire and it's the area. So if we want to decrease the resistance, we have to increase the A. So if we increase the cross section, so again, it will be expensive, it will be heavy. So it's not a good option. On the other hand, we can decrease the lengths. If you decrease the lengths, you can decrease the resistance. However, in order to do that, we have to bring the power plant close to the consumer. At the Edison time, it was impractical. Now we have this. We have the renewable energy on the roof, solar panel, but at that time it was impossible. So the lengths, we cannot change it. So what should we do if we want to increase the power? What's your solution? Guys,
Increase the voltage.
Increase the voltage.
exactly. What was the problem with the Edison system? Why didn't he increase the voltage? Do you know what was the main feature of the Edison system? So we know that if Edison increased the voltage, he could increase the power. Why didn't he do that? He could use the transformer to increase the voltage. Are you agree?
You can't increase the voltage every time you need higher power. It would be very difficult.
No.
It was a DC system and he needed thicker cables each time he increased the voltage.
No. Other opinions?
The transformers cannot change DC voltage.
Exactly. You know what's how transformer work. So our transformer are AC, but the main property of the Edison system was DC. So we couldn't increase the DC voltage with transformer. That's why we reject the idea of Edison and select AC system, because we had the technology to increase the AC system, because we want to increase the AC voltage to have to increase the power. That's why we use AC. As you can see, the transformer cannot change the DC voltage. And it was the Tesla solution that we can use AC instead of DC. Now we are working with the AC, but the technology improved during the time. And now we have the high voltage DC as well. But at that time in 19th century, they decided to focus on AC because they have enough technology to increase the voltage. It was the idea of Tesla that we have a power plant far from the cities. The produced voltage is low, but we can use transformer to increase the voltage and send it to transmission line. With the high voltage, we can reduce the loss in the line. Could you say why we can increase and decrease the loss in the high voltage? Which variable are in the expression of the loss in the transmission line? In the resistor, for example, in the simple case?
Can you hear me?
Yes.
By increasing the voltage, you reduce the current, and the current is a part of the equation.
Yes. And in the simple equation, even, sorry for that writing, for simple R, loss, how difficult it is, R square, Ri square. So when you increase the voltage, you decrease the current, so you will decrease the loss in the power in the transmission lines. However, we have a distribution system as well, because we have a specified voltage for the consumer. We have to decrease it again. Here we increase, send with high voltage, and again decrease to be available for the consumer. It was the Tesla solution for the AC system. And finally, Tesla won the fight, and now we have AC system. However, power system. We have four main elements in the power system. We have power production, it's the power plants. We have different type now. We have renewable as well, but generally it is production of power. Transmission line, it's the next element. Distribution is this part, decrease the voltage and distribute to power consumption. We have different load in the system, and these four elements are the main elements we have in the power system. But of course, we need monitoring and the control system in the power system. So the power system is a very complicated, and if you want to control it, you need a monitoring as well. So this figure can better show you the different section: generation, transmission, distribution, and the load. Remember these digits because it's very common, but it can be different in different standard in different countries. But it's common to have this voltage for transmission and this voltage for distribution and consumption. For the generation, we have traditional fossil fuel based power plant and the renewable. Could you tell me some renewable energy? Just a name?
Wind power,
Yes. Next.
hydropower plant,
We have more in Norway. Next.
solar panels.
Do you think, is there any potential in Norway for the solar panel?
I guess in the summer, but not like South Norway could use some solar panels, but in the north, it will be bad in the winter at least.
And according
In
to
the
the
north, yes,
costs,
yes.
yeah,
In the north, sun power is impossible.
and
But
do you think,
in Norway, you have a lot of water, so water power is the best idea.
okay. And is anyone worked with the solar panel before to get some experience? No. Okay, the next renewable energy you can remember?
Wave power.
Wave power. Yes, ocean has many potential. Yeah, the next. Can we use Earth?
I don't think so, at least not now.
Nuclear, isn't it?
We have thermal energy as well. We can send water inside the Earth. In a very simple definition, we can make it warm and then return it back to the surface. We don't have it a lot, but we have this technology. For example, as a case in the Earth. Okay. Power transmission. We have a new technology for high voltage transmission line, and it's 100 miles. It's very important property, and the transformers. And for the distribution, again, we have transformers and the medium voltage transmission line, and the power consumption. We have different type, industrial, commercial, residential loads in the power system. And one of the most difficult things in the power system analysis is how to model a load, because there are many parameters that affect on the how to model a load in the power system. So it's a picture from the monitoring room. So we have a power system, and we need some measurements. For example, you want to decide which power plant and how much power we want to have in the system, and which load should be I didn't get Vegard talking with me. No, okay. Should be trip or not, and different control. For example, we have relay for the protection, we have circuit breaker. All of them should be decided in the control room and the measurement. The first step is measurement, and then control, and then action with actuator. We have circuit breaker to open circuit in the power system. And power grid representation. So you have the background of the circuit analysis. So you are familiar with the branch, the elements in the circuitry. But in the power system, instead of node, we have bus. It's a common term we use instead of node. And instead of link in the circuitry, we use transmission line. So you can see here, it's a very simple diagram of power system. These buses, we call them bus. This black one, we call them bus. It's equivalent to nodes in the circuit analysis. And these are the links or branch in the circuit analysis, but we call them transmission line. And we consider impedance for them: resistor, inductor, capacitor. And for the load, this symbol is used a lot for the load. It's very simple, but it consists of many consumers. As I said before, modeling load is very difficult. When it's very difficult something, we consider a very simple model. So it's very simple to use this symbol for the load. So when you see it, it's load, bus, and the transmission line and generator. Here, suppose that probably you heard about load flow. It means how the power flow in different direction in the power system. For example, if you have 3 megawatts load in this bus and 7 megawatt in load in this bus, so the sum of these loads will be 10. So we need supply from the generator. We need 10 megawatt production and 3 megawatt consumption here and 7 megawatt here. So power flow depends of the structure of the power system, and its inherent property of the power system to decide how much power will go from this line, how much power will go from this one. But we have the new technology that we can manage. For example, according to the topology of the system, consider that 1 megawatt will follow from this line, but we have a new technology that we can increase it from 1 to 1.1 or 1.2. It's very limited, but we have this technology. But most of the time, the topology of the system will decide how much power flow in each transmission line. It was a very simple definition for the power flow. And in Norway, and it's in Norway in 2011, the power system, and 2030, they anticipated we will have this system in Norway. As you know, Norway has a very good potential in renewable sources. Do you know which one is the main resource in Norway, renewable energy?
Water.
What?
Water.
Exactly. We call it hydropower as well. So I think 99% production in Norway will be hydropower. And we have a different standard. And in Norway, these digits are considered for the voltage. For example, for the distribution, these are the main, these are the standard in Norway. And it's for the regional and the transmission. In Norway, we have transmission system, regional system, and distribution system. But in the other country, these two sections are combined as a distribution system. We don't have any regional system, but in Norway we have. And talk about that. And TSO and DSO. We want to get familiar with these words. TSO and Statnett is a TSO in Norway as a transmission system operator, and the DSO, distribution system operator. And we have one TSO in Norway, and it is Statnett, but we have different distribution system operator in Norway. Yes, it was a simple introduction to power system. So I had to do it yesterday. But I finished now. Okay.